with and our advisor is Dr. Lee is here, and here's my awesome teammates, Timothy, Mike, Leo, Tim, Aiden, and Cindy. Today we're gonna present to you our demonstration of our senior project. Its name is the 3D flight trajectory visualization system. Now I will take you back to the 1998. There was a terrible accident, airline accident. In the year 1998, there's an Airbus crashed into a road near the Taoyuan International Airport, and all the crew are dead, all the passengers are dead, and the accident actually killed 7 people on the ground. So that makes the total 203 fatalities. That was the most terrible accident in Taiwanese airline story. And now next to the year 2000, that's another terrible accident. The Boeing 747, it took off from the wrong runway during the typhoon, and it was destroyed. Of the total 20 crew, 4 was dead. Of the total 159 passengers, 79 was dead. So 83 people was dead in the total 179. So even though in airlines the accident rarely happens, but when it happens, a lot of people will die. Actually, the probability of survival is very low. Like you don't have any chance to survive at all. So how to prevent these accidents? We learn from the worst. So like in any other accidents, like car accidents, ship accidents, we have something to record the accidents. So we review the accident to learn from what happened, so how to prevent it. But for airlines, we cannot record everything. Actually, we have no way to record the flight. So some smart people, they think of a way to use a flight data recorder, we usually know as black box, to record all the parameters during the flight. But just one problem with this black box. There are too many plain data, text data. If you are not a professional, if you do not have enough experience, you cannot understand all of this. And even though if you understand this data, it will take you a lot of time to review on the trajectory, review on the information. That's why, ladies and gentlemen, I introduce to you our software solution, 3D FTVS. And now my friend will introduce what is our 3D FTVS.
Good afternoon, everyone. I am here to introduce on what exactly 3D FTVS is. As you can see here, 3D FTVS stands for 3D Flight Trajectory Visualization System. And this is a list of simple things that it will take care of. One is that it will visualize black box data. From the previous slide, you saw all the collective junk of information that's all mashed up together. What we want to do is want to take that and put it on a visual representation, which is Google Earth for our system. Next, we want to have trajectory playback. We want to be able to take all that data and turn it into a running file, so you can see what the plane is doing, where it's at, and all the information is displayed. We also have trajectory comparison, which is basically showing the predefined path of the aircraft along with its current path, where it's at. We also have the smart camera view, which is you are not only confined to one view of the aircraft, where you can also change it from 3 view, where you can change the zoom, the tilt, or such factors of the plane. And we also have the graphical instruments display. That is important because the black box data will be run into our system, where we take all the numbers and crunch them onto our instruments. Now these basic instruments include such things as the altimeter, the vertical speed indicator, the heading indicator. Very fundamental things for an aircraft. We also have 2 separate subsystems. Now those are the main point of our system. We have 2 things which will work in tandem together to produce our end result. Now, one of those is the converter. Simple as it is, it just converts files to the preferred version that we would like to use. And our other one is this, the 3D FTVS website. Now this is a web-based application, so this will be accessible through any browser. And from the left side, you can see we begin with our directories. tab. This is where you will have all your trajectories stored and automatically loaded onto Google Earth. To load these, you simply click on one of these trajectories. And that is the Google Earth instance. We have our playback menu here at the top left of that screen. We also have the instruments in one of these 3 tabs. Now, as you can see here, we have included all the instruments. And under the text info, we have the text information at that current point. Under more options, we have options to control the view and instances of Google Earth as status and so on and so forth. Next slide. Now, for the 3D FTVS website, this is also some properties that we have for the system, as you can read here. Such things as it being cross-platform, multi-browser support, as I mentioned. Minimalist user interface, it's simple to easy to use. Flexible camera view, as I mentioned before, and trajectory options for comparing. Next slide. This is the other part of our system. This is our converter. And yes, CSV to XML. XML is the file format that we prefer. And files that we have from the black box are all in CSV. So we would take that and use our converter to turn it into XML format. Now, as you can see, it's deadly simple. Input, output, convert. Easy as that. Also, it is optimized for performance. It does what it needs to do without doing anything flashy. Now, I will give this to Mike to also introduce this part now.
Good afternoon, everyone. Mine is to describe why we think our system is good for airlines and why we. Okay, these are the reasons we think it's useful. It is very simple. You can take absolutely no time to learn it. To learn to use the system. It is quick to deploy. There's no need to install any software. And it is also easy to maintain and upgrade. You can use minimal resources to upgrade it and maintain it, and totally free. We didn't use any money to develop the system. And these are the development metrics, which are the number of lines of code lines. We have 4,049 lines of codes for Java and 3,666 lines of code for HTML and JavaScript. And finally, we have PHP lines, which are 103. We have used the software that we use to generate this analysis is called Code Analyzer. Now we can show you the demonstration of our system. Okay, this is the bunch of colors that have been extracted from the black box. As you can see, you cannot understand what the meaning of this whole thing is, and it's hard to use. So we had to convert this, because this file is in CSV format. So we have to convert it to XML, which is more useful. Let's see the CMS there. This is the converter, user interface. If you want to convert the CSV file to XML file, you first go to the browse button above and select the desired CSV file, open, then come back to the GUI, go to the second browse button, then you create an output folder. Then come back. Then now you can convert it. You can convert the file. This is the foundation. Now this is the XML format data. It is much similar than the CSV format and useful. You can now use it to simulate the trajectory of the flight. how to play. You first go to the URL tab here and get the address of our system. You wait until Google Earth loads. Then you select your desired XML file that you want to replay. To play back the project, you need to press the play button in order to start. Once the play button has been pressed, you've got other options. You can either stop the project or skip to another frame using the fast forward or the next frame button. Now the game is playing. This is how to change the options during playback. As you have seen from the previous slides. This is to move from one frame to another frame and go back to the previous slide as desired by the user. And we also have 3 tabs here, which is the graphical instrument tab, the textual information tab, and many more options. This is the altimeter and the turn and burn indicator, vertical speed indicator, speed indicator, and finally the heading indicator, which are all used inside the cockpit.
So this option is the original data, right? What's the original data looks like this one, right?
Yes.
Okay, and then what did you change it after that?
We have converted the CSV data into XML usable data.
Right.
Yeah.
And then you have
So this is the playback from the XML.
Okay. And then you said that you have the option to change. What kind of option?
Change the view of the camera.
This is all the option to change the view.
You will see later.
In and
So you change the view.
so this is the textual information if you prefer textual than the graphical information as the plane flies. And these are the other options. Here's the status bar. As you can see, pop-ups on the grid. You can see the change on the screen as you check the boxes here. Draw trajectory. These are all the options that we have, and these are the view options. The body view, you can view the plane from the sides, and the tail view, you can view the plane from the rear, from the tail, and the cockpit view, which is basically the pilot's view. This is the perspective of the pilot. Okay, that's all for the demonstration. I will pass the mic to Hans.
Because the software is not yet finished, so we still have more room for improvement and implementation. So as you can see, right now we are playing the airplane as a whole. So we just move the airplane as a whole, but we plan to implement the source code to move different parts, separate parts of the airplane, just like the flap, the wings, the tails separately. So when you change the camera view, you can see all the different parts moving according to the black box data. And also we plan to implement the free flight function. That's why you don't need to replay any black box data. You can just control the airplane using the keyboard to fly as you want. Those are for the future implementation of us. And now we go to Q&A sessions.
So did you test that in case something happened, then you see the trajectory how it looks like?
Well, it depends on the data.
Right, I know.
Yeah.
Did you test data that's assume that something happened, then looks how it looks like?
Well, we don't have the real data for that.
So those are the data that you got. Those are the real data, right? That for your simulation.
Yeah. Well, the CSV is from China Airlines. They gave us, but the sample trajectory that you see during the playback is created by us. It's created by Dr. Yu. He gave us those sample trajectories.
So that's the real data.
Yes. Dr. Wang, do you have any questions?
Yes, give any questions? There's somebody asking questions.
Okay, just see please.
Can you display multiple aircraft at the same time? For example, an accident might be a result of two aircrafts flying in a certain way.
Well, right now we only support play one airplane at the same at one time. So that will be in the future implementation.
Thank you.
So any other questions?
Question.
Yes,
So I want to give some for the questions Jesse asked. I think the system they now created can play multiple airplanes at the same time. But because they only need a switch to switch to the desired airplane. Actually, in the current system, you can play different airplanes at the same time. Right?
Kind of.
Yeah, just I use the switch. For example, maybe a key. When you press a key, then the pointed the index to the airplane you want you want to see the trajectory of that. And actually, I have a same system, so designed by myself. And I want to say some things about the senior project of the Hans. They follow the idea of mine, but they use a different approach for the same system. Although only maybe 60% of the function are implemented in this, but I think they will try their best. So I'm very proud of their best.
Thank you.
Thank you.
Any more questions? You sure? No questions about the project, the senior project, the future project when you Yes.
Can each of you tell everybody your job and duty in the project? What is your accomplishment, major accomplishment in the project? What is your duty and your major contribution to the project?
My contribution to the project was design of the converter, handling of the altimeter instrument, and design.
The code converter?
Yes.
I also worked with the converter and also the vertical speed indicator, the endorsement instrument, and the documentation.
Vertical
Speed indicator. Vertical speed indicator. Yes, and the documentation. The one
So what kind of tool you use?
the tool. As in
Software tool you use for the vertical
Eclipse. Java and Eclipse.
My job is to make a airspeed indicator and help him to do his job is vertical and horizontal together. Yeah.
My job is creating a tenant band indicator and a document.
你是什么 indicator？
Tenant band.
Tenant bank.
I also have the document.
Why there are so many people doing documentation?
But the document is very long.
Many parts of document. I also do a part of document and horizontal.
Document for the final file.
And for me, as the project leader, I assign job to them and help them with, if they have trouble, they can go to me and ask me for solutions. And also, I'm responsible for force them to finish their task on time.
Okay, I have a question. How long for you guys to accomplish this project?
Well, we start during March,
Okay.
and we just finished it like 2 weeks ago. But then every day we don't work. We don't work every day. And like let's say 1 week we work for 1 or 2 days and like 1 or 2 hours per day. So if you accumulate all the time, it will be like 1 month time.
Okay. What conclusion you have for your project? And say, do you learn some new lessons or knowledge during the project?
Yes, we did learn a lot of things about aeronautics knowledge, how to control the airplane, how the airplane operates, and those.
So any words you want to say for the junior or freshman, say, give some projection.
Alright. Well, for juniors, no pain, no learn. You don't choose your members. You don't choose the topic. So you must know everybody. You must know all of your classmates. You don't know who you will end up with. Get to know everybody.
What is the most challenging task in this whole year?
Group encouragement and how to let everybody work with each other.
Teamwork. It's the most difficult. Do you think that teamwork costs you more time than technology side?
Yes, definitely.
Okay, I give you one suggestion. See, I see your slides in here. Okay, you have questions and all of them content here. I think also give the other guys. If we in the future I see your project from slide, the last slide should be critical thinking. Okay, you should give some, how think about your project, any lesson, any problem, any suggestions. Just give the reference for the other people. Okay.
Thank you. No, you can see the development network. Yes, these are the total lines. You can see the total lines 7,801.
So you use JavaScript.
Oh yeah, we combine many languages. So if no more questions,
One more question is just give everybody just a quick idea for the complete job. How much percent of technology you learn by yourself, not from the class teacher?
well, just like Pamela said here, it's almost 100%.
So that means class knowledge.
No, actually, class means class teaches the basic, like how to learn the programming language, what is IDE. But like for this project, like, we use the different IDE from what we learned in class, and we use different language, different technology.
But I remember in the JavaScript, PHP, I told you guys during the web programming, right?
Yeah, but we don't use macro media, so we use HTML.
So it's her. Yeah, it's her.
Okay, we hope they can finish this by the end of this year. They're going to give another presentation by the end. Okay, this is only halfway through. Actually, they're expecting more bugs. Remember the 80-20 rules. Costs more time, 80% of time, doing debug and the fine tuning. Right? So I will see they will have more fun to go. Well, good job. Okay, let's give them a warm applause.